Molarity notes. So solutions. 1, molarity. So, as we always do when we start with these notes, what do you see in the word that we're trying to learn today? Molar, right? So, when we see molar, we should start to think of moles. We should start to think of Avogadro's number, 6.022 times 10 to the 23rd power. This is an amount, a number of particles. An amount. But then, what does the suffix "ity" have to do with it? How do we define that? Usually it's like having to do with. So, we're having to do with moles, okay? And we're talking about solutions. And so that's where we're going to kind of start, is talking about these solutions. We have 3 words that we absolutely, without a doubt, need to start with. What is a solution? And I don't mean like the answer to a problem. Let's think about some examples. Salt water is a solution. Air is a solution. Brass is a solution. What do you think? Okay, so after we put some things together, we have... Okay. What about this word? It is a mixture that is consistent throughout. Like iced tea is a solution. I cannot see any chunks or layers in iced tea. I said brass was a solution. Think about brass, the metal. It's all the same color all the way throughout, but it has different components. Okay. And these parts have names too, and these are solute, and solvent. Solute is part of the mixture, or part of a solution. We'll put a solution because a solution is a special type of mixture that is dissolved. So, let's use the example of salt water. Okay. The solute, what is dissolved in salt water? The salt, right? Oops. The salt is dissolved. So the solute would be the salt. Right? The solvent is the part of the solution that's doing the dissolving. So part of a solution that is, and that's a lot of words to write, but I'm going to write it that way because it's very clear. The solvent is part of a solution that is doing the dissolving. So if we come back to our example of salt water, if salt is being dissolved, what is doing the dissolving? The water, right. So even though that seems kind of obvious, at some point you're going to be asked questions where you're going to have to really think about it. Okay, what is being dissolved? What is doing the dissolving? Okay. most of the time, water is going to be your solvent. Most of the time. So let's make a little note. We'll change the color a little bit. Maybe. Water is the universal solvent. Make sure. Now, why would we call water a universal solvent? Does it dissolve almost everything? Yeah. I mean, and that's, water will dissolve a whole lot of things if given time and enough of it. Okay, but it also has to do with the properties of water, which we talked about a while ago. But the polarity of water, the cohesion and adhesion of water help it to dissolve lots of things. So most of the time in this class, water is going to be our solvent. Okay. We kind of talked about examples of solutions. We said salt water, iron, brass, air. Those are all solutions. But the ones that we talked about, like sweet tea, salt water, you might follow a recipe for those, but when we're in chemistry class, we have to be very specific. So we use agreed upon concentration. So let's write the word concentration and talk about it just a little bit. Concentration. I'm not talking about when you think really hard on something. But when you see the word concentration, we're thinking about solutions. What does that word mean? Think about your sweet tea. Huh? What? Okay, how strong it is. That's good. Like if I started to say, think about your sweet tea. If I put a teaspoon of sugar in a gallon of tea, is that going to make it sweet tea? No. But if you're like my son and you put 2 cups of sugar in a gallon of sweet tea, that's some sweet tea, right? So your concentration is how much solute per solvent that we have. That salt water thing. You guys ever gargled salt water when your throat hurt? If you don't put enough salt, it's not going to do it. It's not going to make it work. But when you put enough salt, it's gross. So, concentration is how much solute is in your solvent, or per, I guess you could say, or per an amount of solvent. I liked what she said about how strong it is. That's a really helpful way to think about it. How much are we putting in there? Now you guys know this is chemistry, this is science, so it has to be very consistent. When you do an actual lab journal or research, say you're working at Lilly and you're trying to find a new medicine, or you're working at Dow and you're trying to figure something out, somebody else has to be able to reproduce your work. And so that being able to reproduce your work is definitely a huge part of concentration, because concentration is so important to anything with chemicals, anything in the medical or that kind of field. So we have a certain word. Concentration is very highly related to molarity. And that is having to do with moles. So molarity, concentration and molarity are very interchangeable in some ways. Molarity equals how many moles per liter your solution is. So let's write that in a, like, more mathematical way. Okay, moles of solute. We can't have grams. We can't have units, but moles of solute per liter of solution. Now, I want to kind of make a big hairy deal about this, okay? So, liters must be liters. And I say that with all capital letters, like screaming it at you, because almost every single time you do a problem like this, they're going to give you milliliters. Almost every single time, you're going to have to change milliliters to liters in order for it to be molarity. Because if it's not in liters, it's not molarity. Okay? So we want to kind of get that in our head. We have to have liters. If your answer is in milliliters, particularly when you go to do the CK12 stuff, some of you will get super frustrated with it because you will do everything exactly right, except you'll put your answer in milliliters and it won't be right. So, and we show this with a big M. Okay. So, you will need to make sure that you remember this moles over liters. Lots of times, well, we never measure out moles. What do we measure out? If we're going to get, say, salt or sugar or some chemical from the science lab, what can we measure in? We can't measure in moles. We can measure in grams, usually. So when after this must be liters, we'll put some notes here. Make sure you change grams to moles and milliliters to liters. Okay? Alright. Alright, so if you were in the lab and you're trying to make a certain molarity of a solution, you would do 3 things to make a solution. To make a molar solution, with a certain molarity, you would calculate the number of grams needed. So calculate the number of grams needed. Add the grams of solute to your flask or beaker. We'll just say flask or beaker. And then you add the water or your solvent. A lot of times they'll make 1,000 milliliters or 1 whole liter of solution. Sometimes we don't. So we want to maybe say to the desired volume. I'm gonna put a little star there. Often 1,000. Oh, sorry. Thank you. Often 1,000 milliliters. Okay. So I'll let that stay on the screen for just a second, and then we'll do a few math problem examples. I'll give you a break. So you got to kind of put yourself in that lab situation. If I need a very specific concentration, a molarity of solution in order to make it work, then I might have to go create that molarity. I might have to go actually do that. And that's one of the things that you will do in Chem 2. Okay, when you go to that, if you go to that. Alright, I'm going to go ahead and turn my page and we will do some example problems. Okay, so if you have opened up the notes that are in today's lesson, you can see that as well. We're going to do a few of those examples, but not all of those examples together. So that's why my numbers won't be exactly consistent, but I think you can. So this is example 1 from that note sheet that's in the lesson, and it says how many grams of calcium chloride are needed to produce 500 milliliters of a 2.50 molar solution. So we're back to the math again. Let's go ahead and write that down. How many grams of calcium chloride are needed to produce 500 milliliters, so half a liter, of 2.5 molar solution. So we'll kind of shorten that question just a little bit. The first thing that we got to look at is, all right, calcium chloride. I know that I'm going to need a formula for this because back in our notes we talked about moles. So in order to figure out grams to moles, I know I'm going to have to figure out a molar mass somewhere in there. So if I look at my periodic table, I know that calcium is going to be a +2, chlorine is a -1. So when they flip-flop, when I crisscross them, I'm going to get calcium with a 1 that I don't need to write, and then chlorine is going to have this 2 that I do need to write. So there's the formula of my stuff. I know that I need to end in grams. I'm given this 500 milliliters and a molarity that I want to get to. So I'm going to start with what I'm given. That's what we always have to do, right? We always have to start with what we're given. And I'm going to think, all right, wait, there was something in the notes about milliliters. So we'll go back and look. Said must be liters. Make sure you change milliliters to liters. Okay, we can do that. So that'll be our first step. We got 500 milliliters, and I know my teacher was all cranky about make sure it's liters. So I'm going to say, all right, cancel milliliters, come up with liters. 1 liter is 1,000 milliliters. All right, now I have liters. What do I do? Well, let's go back to our question. The only other number I'm given is 2.5, this big M. If we go back to our notes and think, all right, what was big M? That's moles of solute over liters of solution. I have liters, so I can use the molarity in my problem like a conversion. That right there is the big deal about today. You gotta be able to remember that molarity is also a conversion. So let's use that in this problem that we got. Alright, so if I know that this right here is actually 2.5 moles per 1 liter. Now I can do something with it. So I want to get rid of liters. I'm going to leave it just like that's written. 1 liter on the bottom. Because, okay, my milliliters canceled. Now my liters are going to cancel once I get my conversion completed. Okay. So now I would know that I need 2.5 moles of calcium chloride. Is that what my question asked me for? No. Question asked me for grams. So now I need to go moles to grams. I need to find the molar mass of this calcium chloride. So let's do that down here. I had 1 calcium, I have 2 chlorines. 1 calcium is, we'll just do, what many significant digits were given? Just 2. Alright, well, we'll just do 40 for calcium and 70, well, it's 35.5. So when we multiply that out, it's 40 and 71. We add them together, 7, 8, 9, 10, 11. We get 111. So that 111 is the molar mass of calcium chloride. Shoo-wee. Alright, so when we calculate it out, get my calculator up so that we can see the math. Alright, so if I calculate it out, I'm going to go straight across the top. 500 times 1 times 2.5 times 111 is 138,750. Shooey. And let's look at the unit that we'd still have. Milliliters canceled, liters canceled, moles canceled. I'm left with grams. And across the bottom, I'm going to go 1,000 times 1 times 1 is just 1,000. So, and I, just for clarity, divide by 1,000. I'm going to get 138.75. Let's see, we'll write it here. And so we had just 1, just 2. So we could just say 139 grams calcium chloride needed. I know. Okay. I know that there's just 1 significant digit in the number that we're given, but if we round it off to 1 significant digit, we'd say 100 grams, and that would change our concentration a lot. So sometimes we have to be mindful in the real world. Those significant digits need a little leeway. Okay. So give me a thumbs up if that math made sense and you kind of followed it. Okay, good. Good. Big deal. The big deal is using molarity as a conversion factor. Okay, and following your units. This factory label unit analysis business will never leave you as long as you're in some kind of academic science class. Alright, so that's the first example. If you're looking at those notes that are in the lesson, the second example is a lot like it. So we're going to skip that one and we're going to go to number 3 in that note sheet. And like I said, I'm giving you these examples so that when you do the problems in CK12 or you do the problems on your other work, you will be able to refer back to them. So it's really important that you do these that you do write them down. So number 3 says, what is the molarity of a solution when 20 grams of sodium hydroxide are mixed with water to form 333 milliliters of solution? Alright. So the first one we were asked what was the gram, how many grams. This one we're asked what is the molarity. And this one we're given the significant digits a little more readily. It says sodium hydroxide. So we know sodium is a +1, hydroxide is a -1, so we can just write it out like that. So sodium hydroxide are mixed with water to form 333 milliliters of solution. Okay, so let's digest this question. Molarity, we learned earlier, is moles over liters. So I gotta somehow get moles over liters out of these numbers I'm given. Now let's think in the real world for a second. If I'm putting these things together, okay, I'm gonna put 20 grams of this into 333 milliliters of solution. So I can go ahead and just write it like that because I am realizing that this is a real thing. I'm doing this supposedly in the lab. So then I need to get to moles. So following our units, if I have grams right here, I need to cancel grams and I need to come up with moles. Well, that means I need a molar mass. So we'll come back to that here in just a second. But our grams are going to cancel. That way we'll have moles on the top. If I'm asked what is the molarity, I need to have moles on the top. Then I look at the bottom. I'm putting this in 333 milliliters. What was that big hairy deal I made a little bit ago? It has to be into liters. So I need to convert this to liters, but this time to convert, my milliliters have to be on the top to cancel, and my liters will be on the bottom. So when I have milliliters, that'll leave me with liters on the bottom, and that's what I want for molarity. So let's fill in the blanks that we had. 1 liter is 1,000 milliliters, and we need a molar mass. So I see sodium, I see oxygen, and I see hydrogen. Sodium is, there's only one of each of these, so we could go ahead and be official. The sodium has a mass of 23, oxygen has a mass of 16, and hydrogen has a mass of 1. So when we add them together, we get 6, 7, 8, 9, 10, 2, 3, 4. Can you not see? Okay, I am sorry. There we go. So yeah, when we add them together, we're going to get 40. So this is 40 grams per mole, and that's going to go right there. So we get our calculator rocking here. Now this is, 20 times 1 times 1,000 is 20,000. Okay. And we can see the only unit left is moles on the top. But then at the bottom, 333 times 40 times 1 is, and that's liters across the bottom. So then we do 20,000 divided by 13,320, and we're gonna get 1.500. So now we can look and say, well, what was our significant digits? We had 3 to start with, and that's a much more reasonable number when you're making a concentration and it needs to be very specific. Alright, so again, part of the big deal of this problem is knowing that molarity is moles per liter. So now we can stop. We have a 1.50 molar solution at that point. Thumbs up if that makes sense. I got some thumbs up. Okay. So again, this molar mass concept will never leave you. Okay. Thinking about doing this in real life, like if I measure out 20 grams of this stuff and I put it in this much solution, I need to see what the units are. It's really about the units in a problem like this. All right, what time? Why don't we have like 10 minutes left? Why don't we go ahead and stop with the notes today on this? We have some good examples and you kind of got the idea there, and you can go ahead and do the vocabulary. So kind of take the math brain down for a second. You can go ahead and do the vocabulary definitions. You want to get all 20 words moved over to mastery. Okay. And then just submit your screenshot, the full screenshot that shows your whole screen with the time and all that jazz. The full screenshot to today's lesson that shows you did the vocab words. Okay?